Hello and welcome to another CIQ webinar. We appreciate you joining us. Good morning, good afternoon, good evening, wherever you are. So today we decided we want to talk a little bit more about Singularity Apptainer. Apptainer now, I typically am messing those up. So Apptainer, we want to talk about what it is for securing a container and signing it. And today we have Jonathan Anderson, Forrest Mert, and I think Greg is here as well. Sorry, Greg, I keep calling it Singularity. I can't unwrap my brain. Eventually I'll get there.
It took me a little while too, as you can imagine.
Man, so
years of calling it Singularity.
Absolutely. So thanks for coming on today, guys. Really appreciate it. I think everybody knows Greg and Forrest. You guys have been on here a bunch, but Jonathan, you're new.
Yes.
Tell yourself, where you came from, what you do for us.
So I've been all over the kind of academic HPC space. I've been in the national lab system a little bit in the university space. I've been an HPC sysadmin for most of my career, working on some of the top 500 systems, but also some systems here and there at different scales. And really glad to bring that experience to CIQ and start solving problems here for us and our customers. Oh, my mic is loud. I'll back up.
Sounds good to me.
Yeah. All right.
So Jonathan did not mention how he is the supercomputing mascot.
Yeah, there's a picture of me that floats around with me in the way background that you might see and not know as me.
That's awesome. I wish we could pull that up. I wish somebody told me. I would have had that ready. So yesterday when we started talking about what are we going to talk about today, I think there were a lot of different topics that we could have covered. And Jonathan, I know you and Forrest spent some time working on something to show us. But first, talk to us a little bit about signing a container. What does that mean, and why would I do it?
Sure. So Apptainer signatures are based around OpenPGP, which is a relatively long-standing mechanism for traditionally what I am used to seeing it as is signing emails in a way that lets you verify that what you're receiving is from the person that you expect. It works on this idea of a web of trust where you have a key. So it's an asymmetric key. So you have a public and a private component. And then through some out-of-band mechanism, you exchange your public keys with other people that you want to correspond with. And then you can submit assertions of trust into some kind of key server. And there are a few, but we'll be dealing with kind of the most standard. I think it's just openpgp.org or something like that for Apptainer. And so through your relationship with other people, you can say, I have trusted this person. I know that I have their key, but you can also trust that other keys that they have verified are also likely to be the right person. Or in this case, the right author of a container or the right organization. But there are other ways to get keys as well. You could imagine downloading a PGP public key from an HTTPS protected website from a company or something like that. And then from that point, you can verify that containers that you've pulled down are valid from the point of their publication.
So having you talk about keys and keys from here, keys from there. So obviously a lot of different keys could be involved. How do you deal with a bunch of different keys? Is there somewhere that they live? How do you get them? Where do you put them?
Yeah, so generally speaking, there's some kind of database on your local system in what's generally called a key ring. But then the public key material you can just upload because it's public to any random key server that you want. And then you can use those key servers to pull down other public keys as well. But locally on your system, you'll have a key ring of public keys of other people and your own that you trust to various degrees or with various degrees of certainty. And then a private key ring that stores the secret material for keys that you own that you can sign with. And there's a key ring in, like, I have the PGP keychain app installed for Mac OS, but then Apptainer has a key ring also that you that it will use by default, both for verification and signature.
Thank you for that. So I know you're going to show us a little bit of this, but from a user perspective, maybe I haven't done this before, and give me an example of when this would make sense or why. And I'll open this up to everybody. I mean, Greg, I know you have thoughts on this as well, but tell me something, when and why.
So from my perspective, the point of containers in general is, or one of the biggest points is portability and the ability to kind of publish a workflow and then other people benefit from that workflow. And so there's this kind of typical uh, other kind of workflow, a typical way that people work of, you develop a container and then you push it up into a container registry or an artifact registry of some kind. Those may be private registries, and then maybe the signatures aren't as important because you have to authenticate to the registry. But lots of these registries are public. And with standard web stuff, we decided to protect that. We as kind of the general internet community protect that through TLS signatures, X509 signatures on HTTPS websites, where you can verify the identity of the server that's serving that material to you. PGP signatures on a container are a way to do that in this other space. Maybe you trust the website or the container registry that you pulled a container down from, but now that container is just a file that's sitting on a file system floating around. Who knows where it came from? One of the benefits of the Apptainer mechanism for signatures, particularly with CIF container formatted files, is that the certificate is bundled with a single file. So there's no separate signature file that you have to manage or keep track of. It's just, if you have a container and it is signed, you can verify that that it is signed by the entity you expect or someone else.
No, that's interesting that it's all there together in one file. I'm not having to lug around a bunch of different things. And I hope that you'll show us how we can see that here in a minute.
So what I can add in a little bit to that. So early on, as containers were starting to really gain in popularity, and we were just starting with Singularity at that point. We were just starting to integrate with the registries that Docker had up there. Before OCI was a thing, it was just Docker Hub, and we were basically pulling containers down from that interface. The questions started coming up over and over again, which is, right, we don't just go and install random RPMs on our system that are not cryptographically signed, that we don't trust, right? We may be pulling packages off of various mirrors for updates, but they all contain a signature, and each one of those signatures can be verified by the material, the public key material that we have on a particular system. So it doesn't matter where we get an update from, what mirror it came from, we can validate the authenticity of that package and that update through this asymmetrical key method. So, but what are we doing with containers, right? We're in many cases, we're downloading containers that we don't know where they came from. We don't have clear visibility on who has touched them, what is the provenance of that data and the material within those containers. And then worse, we're actually executing those on giant computers, giant supercomputers in some cases. And in some cases, even worse, we're even doing that as root. It's like, yeah, okay, hold on. Let's back up a little bit. We got kind of a major security vector here going on that we have to be thinking about. So the idea of this was, how do we trust? How do we guarantee the trust of any of those containers and all of the material within those containers in such a way that we feel like we can leverage that. We feel like we can trust that. Not only can we guarantee, kind of who it came from and where it came from, but we can also guarantee that it has not been tampered with since then. So these are really good reasons why I think everybody should be thinking about, cryptographic trust and validation of anything that you're going to be running on your computer or leveraging. And it's just to keep going on this for just a second. It's not just Linux. I mean, if anyone has a Mac and you go to try to download an application, you're going to have to, and it is not cryptographically verified by Apple as going through the trusted mechanism. You have to jump through some hoops just to get that thing to work, right? This is a much simpler interface, and it works extraordinarily well, and it integrates with standard mechanisms that we're currently using within the industry for dealing with key material, everything from standard PKI to standard HKP protocols, et cetera, et cetera. So that's kind of some of the background there I just wanted to throw in.
No, that's great, and I appreciate it. One of the other things that I wanted to point out, I know Jonathan, you kind of spoke about this last night, is we're talking about cryptographic signature. We're not talking about encryption. That's a completely different topic and different conversation to be had. But right now, we're talking about cryptographically signing a container, right?
That's correct. And Apptainer does support encryption of containers at rest and during execution, but it's handled through a completely different mechanism. So I expect at some point we'll have a demonstration about that. But for today, we're going to keep it simple and just talk about PGP signing.
Very good. I just wanted to make sure that we clarified that before we get started here. So I guess go ahead and start showing us the generation and exchange.
Yeah, great. So I've just got a terminal open here with a very simple container. This is just a hello world container that I threw together real quick. It's based on the Alpine base package or base container. Mostly, this is all just so it'll be very small and easy for us to. Oh, sorry, I'm getting some disturbance around the share. It's really small and easy to upload and download. So quickly for the demo. So the first thing I'll do is build this container. It's just one thing to note is that because Apptainer supports this fake root mechanism, I can do this just as my regular user. So I'll end up in just a couple moments with a CIF file on the other end of this. And here we have a really basic CIF file. It's built out of parts, and we'll learn a little bit more about that in a moment. But mostly we can see that it's got the squashfs image that's the majority of our file system, and then a couple other things here that are part of the container. But we can't verify it. So if I say Apptainer verify that CIF that we got, it has no signature, so there's nothing to verify. So we can here within Apptainer, and there are other ways to bring keys in. In fact, I'll show a little bit of that in a moment. But we can generate a new key right here within Apptainer and use that to sign our container. So that's Apptainer key new pair. We'll fill in some metadata. And this can take a moment, but it's pretty quick. Part of the issue here is that I've got this running on a relatively small VM, so it doesn't have a lot of CPU power available to it. But it doesn't take too long here to generate a new key.
Seems very similar to creating SSH keys.
Yeah, except for we don't have enough of as much of a progress indicator for some reason. There we go. So with our new key, I mentioned that Apptainer has a key ring in it. We can see the keys that are in our Apptainer key ring with this key list command. And we'll see that we have two. So key number 0 here is my real PGP key. And we'll use that in a moment. But key number 1 here is the one that we just generated. It's our demo key. It has a fingerprint, or the public key has a fingerprint that we can use to identify it with key servers and each other. Sometimes you use that fingerprint to reference this key to Apptainer. Sometimes you use the index, but it's pretty clear from context which one is appropriate. So from here with our new key, we can just say sign our new CIF file. It asks us which private key to use. It's asking us to specify by index, so we can just tell it to use key number 1, our demo key. And because we're using the private key of our key pair to sign, we have to enter our passphrase. You, in most cases, should have some kind of passphrase that protects the private key material, again, because this is all about trust. So we want to protect that private key so that when people receive a container that has a signature on it from this key, they trust us as well as they expect us to maintain security of our private key as well, or our passphrase around that private key. So that way the private key is never just sitting decrypted on disk in case there's a security incident on the local workstation that we're working on, let's say. So now that we've signed it, we can verify our container. We see that our verification happened locally. We're doing this with the local key in our local key ring. We see which key has signed it, and it gives us fingerprint here, and then shows us there are ways that you can sign individual portions of a key, and individual portions of a container, and there are reasons for that we can go into, although it might be more of a discussion at that point. But here we have our entire container verified with that key. So the next thing we can do is show that. Oh, actually, there was one more thing. If we list our container again, we'll see that we've grown another object. This here is the signature itself, and it exists outside of this group 1 and is signing all of group 1. Oh, got a copy paste error here. So it's signing the group 1 set of objects in this container. And the next thing we can do then is sign it again if we so wanted to. And this time we'll use the 0th identity, which is, again, a real one that I maintain and am imported in out of band from the GPG keychain app. So now we've signed it again, and if we list our container, we see we have a second signature here. And both of those verify. In this case, they're both in my local keyring again. So here we have our first signature with the demo that we had before, and our second signature from the second key.
So Jonathan, on that, if I had one of those public keys, could I execute it then, or do I need both?
So container execution is a different question. So by default, Apptainer will allow you to execute containers regardless of whether or not you've been able to verify the signature. You can define policy in the configuration for requiring that the containers that you execute have one or more signatures. So that's part of the execution control list, I think, ECL. And in there, you can say for containers in this path, it must have one of this list of signatures, or it must have all of this list of signatures, or it may not have any of this list of signatures, and control execution that way. Right now, in the verification logic, or the way that Apptainer verifies containers, it just verifies the signatures one at a time. And so something we'll see in a moment is if I didn't have this key in my local keyring and it wasn't available through a server, then verification would fail, and it wouldn't go on to verifying this, and it would just say that verification has failed, even though we may have that second signature. I think that that's a little bit of an opportunity for change in the interface, but there's nothing about the cryptographic signature that necessitates that. That's just a specific eccentricity of the way that Apptainer handles multiple signatures right now. But in theory, you should be able to verify that a container has been signed by any of these keys, regardless of their order or how many of them.
Okay. Thank you.
So now that we have this, we have kind of everything we need to pass this container onto someone else. So the first thing I'll do is push this container up to a key server that we're using internally. We'll use it for purposes of our demo here. This effectively just uploads this container up. I need to log in first. Effectively just placing this container up on a server that Forrest will then be able to access and pull this container down from. And then once that's done, we're going to demonstrate two mechanisms for for key exchange. One is passing around your public key out of band. I'm actually going to download the public key off of this system and pass it to Forrest over Slack it's a file, and I'll just hand it to him by dragging it over there. But then we're also going to push my regular public key up to a key server. And this key has been pushed there before, but it's an idempotent process. We can do it repeatedly with the same result. And if I had added, let's say, email addresses to this key, it would just update the record on the key server. But we can do that now. And then we can export another key. Here I'm specifying an ASCII armored key, but that's only to make it a little bit more palatable if we were copying and pasting the key around in plain text. We're going to export a key into a file. And so here I'm going to export key number 1, which is that demo key that we generated earlier. That gives me this demo key.pub file, which you won't be able to see this right now, but I'm just going to copy that off this server onto my local system and just drag it over to Forest.
Cool.
Super secure Slack communication for
private
keys.
It's a pre-negotiated trusted communications mechanism. And so, I mean, with that, I'm basically done at this point. So I'm gonna copy this over because I'm one more time, because I may have gotten it confused with a version of this key that we were doing before in test. But Forest now has a copy of that key and should be able to take it from here.
And you should be able to actually share the whole container over Slack too. Now that
in theory, this container for sure would be fine that way, because it's not very big. But containers can get large, and perhaps I wouldn't want to download and drag a multi-gigabyte container over to Forest over Slack. I think they might not like that either.
Not if you like your Slack messages from prior to 10 minutes ago.
Yeah, all of a sudden my Slack bill is going to go up a lot, you guys. I've actually seen people sharing containers over everything from Google Drive to Dropbox to FTP. I mean, of course, SCPing them around as well. But having the whole container in a single file makes it really easy just to deal with. And that was always one of the goals going back to early Singularity days, and thus the name Singularity, single file. So going all the way back since then, it was always kind of focused on the single file methodology and ideology. And to the point that was raised earlier regarding the cryptographic validation, what's really nice about this is, again, we're handling this very similar to how like RPM would handle this. So there's no external services that are necessary to validate against. Everything is contained within the actual image file. So it makes it very easy to deal with.
Yeah, I wish we could actually get a show of hands live of how many people are using FTP.
I interacted with one recently for some genomics data that I was pulling down. So they are still out there.
Yep. In a recent past life, I had to build a multi-server FTP service for someone.
Exactly.
Awesome.
I believe there are numerous labs still using FTP as the interface to their archive storage system.
Yep, exactly that.
Yeah.
All right, Forrest.
Cool. I just want to note first off, before I jump into this, that when Jonathan, you sent me that key snippet over, I got a little message on Slack saying that you'd sent a PGP snippet. Like, it specifically recognized that it was a PGP public key snippet and said as much in the notification. So apparently they've planned for it on their end.
Nice.
But yeah, so you can see that. So yeah, we'll jump in here to my component of this. Let me just copy the container URL that I'm going to be using here.
Oh yeah, it's the same one from before, of course, but
Cool. So yeah, so I'm just here in an empty directory. You can see that I've just made this so we can have a place to pull that container down into and pull that, well, the key I'm probably just going to download into downloads, but just to have a place that we can do this demo from. So first things first, I'm going to go ahead and get myself a copy of that container. So I'll go ahead and do an Apptainer pull and then provide that same URL that Jonathan just pushed that container to. So I'll go ahead and do that. you'll see we get this message saying that we're downloading the image. If I go ahead and do an ls, you'll see that it's there. So that was very quick. You can see that I now have that same container Jonathan just built on his machine over here on my machine. If I do an Apptainer sif list, just to point this out, you can see that we have the same components inside of this that we had before, just that definition file this was built from. A couple of JSON bits here that include some metadata that was built into this file when it was created, so like the environment, the labels, stuff like that. We then have that squashfs file system that contains the container file system proper, and then those two signatures that Jonathan signed this with. So you can see this container comes down on my side, obviously still with those signatures. If I go ahead and do Apptainer verify, however, actually I think that might be Apptainer. Apptainer verify, it is. So if I do Apptainer verify and then I provide this, you'll see that this fails to verify. As Jonathan had mentioned, even though one of those keys is out there on a public key server, because I haven't imported his that local key that he created here into my own keyring, the result that we get is it saying that this fails to validate, because as I mentioned, it can only validate one of those keys from that internet location. I still need to import that other one here locally. So I'll go ahead and download that key that Jonathan sent me, which is right here. Just give me a moment. So I'll go ahead and download that. You can see I can do an ls-latr /downloads, do grep demo key. You can see we have that key there. I'm actually just going to go ahead and move that over into here. So you can see we have the key and the container file here. I'll go ahead and actually import this key into the keyring here so that Apptainer can recognize it. So we'll go ahead and do Apptainer key import and then just provide the path to that key file. You'll see that we get the message here that the key with that fingerprint has been successfully added to the public keyring. And if I go ahead and rerun the, well, actually, first off, I'll go ahead and do Apptainer key list. And you can see the two keys that Apptainer knows about here. One of these is basically just a test key that I put in here for something else long lost a lifetime ago. And you can see the other one here was just created and imported right now. So if I go ahead and do this Apptainer verify on this container again, what we'll see is that we should instead this time get a message confirming that all of the keys on it can be verified. Because once again, I've imported that local key into my keyring here on my laptop. And then the other key that this is signed with is sitting at that OpenPGP key store, and Apptainer will reach out and verify it from there. So we'll go ahead and run this. And you'll see we get these two outputs here, indicating that we have a local key being verified. We have a remote key being verified. So this is the one I imported. This is the one that came from OpenPGP. And you can see that we have a listing of the objects that we verified here. So once again, we can see those same objects that we had in there prior to this. And we can now tell that those are verified. So if I just want to go ahead and show, I can run this container. And you'll see that I get the quick little hello world message out of it. But yeah, that is container signing. So
outstanding. Thank you, Forrest.
No problem.
One of the other things I wanted you to talk about, Jonathan, is the format of a CIF. I know whenever you do the Apptainer CIF list, it kind of shows you the different pieces of what's inside that file. Can you talk us through what that is a little bit and then talk about the groupings and kind of how we can use that?
Yeah, I can run through that really quick. I think
better.
that was directed to Jonathan, but yeah, I'll run through that real quick. Let me stop sharing and share this other screen that I have here. So this right here is kind of the standard image that we use to express exactly what is inside of a CIF and exactly kind of what that internal format looks like. And you can kind of see how we represent the ability to both evolve a container after it's created in a verifiable way, as well as the ability to cryptographically sign the entire container itself. So as I kind of touched on there, when we looked at that CIF list, we had 4 different components in there. We had a def file, 2 JSON files, and then that SquashFS file system. Inside of a CIF, you can see this image describes the structure of it, so I'll kind of map what we saw there in the command line to what we see in this image. The global header and the descriptors, we didn't really have a ton of visibility into there. Those are kind of more, I believe, metadata that you would have to go into, a hex dump or something like that, probably to take a closer look into. But for these other components here, we can see recipe definition and labels and environment. Those map to the 3 different components that we saw outside of that file system when we did CIF list. So that one that mentioned that was the def file is actually the recipe that the container itself was built from. The labels and the environment are bits of metadata that can be added during container. They're metadata that can be added during the container build. So labels, I believe Jonathan may have shown briefly at the start of this what that container definition was built from. And I believe he put like his name as the author in there as a label. So labels are just metadata that comes with the container that kind of describes certain user customizable aspects of it. The environment is the actual environmental variable setup that is present with that container. So that's going to be like the path, the LD library path, custom environment variables you've set, things like that will all be contained within that portion of the CIF. The immutable runtime container image is the SquashFS, the actual file system that contains everything the container is meant to contain is within. This becomes immutable because SquashFS is a compressed file system, so you can't really alter that meaningfully after the container is built. And then obviously, signing gives you another layer of verification that nothing has changed within that container. But that immutable runtime container image, when you go ahead and build one of these Apptainers, it pulls down the base image that the container is going to be built off of. And then, within the post section, it goes ahead and runs any of the commands that you put in there. So, DNF installs, compiling software, doing downloads of different things, that type of stuff. All of that is run and put into the container file system. And then when the container build is done, the last step is that it takes that file system and basically, makes SquashFS with it. And you get this compressed file system image, basically, that is that represents everything the container was meant to contain on like a software kind of application level, basically the file system level. So that's in there as well. You'll notice that by default, when we looked at this at the start, there wasn't a signature block there. That's because obviously there's not a generic signature that goes with every container. That is only shown and present there if the that's only shown and present there if a signature is actually attached to the container. And so up here at the top with cryptographically signed, we can kind of see what we had represented when we did that verify with the key, and how it showed we had all 4 of those components, the def file, the 2 JSON files, and then the SquashFS there. You can see how when we ran Apptainer verify, we got that output out that confirmed for us that those 4 components were all verified as a part of that verification operation because they're all signed with that key. And so that's where you can kind of see this concept of the signature allows for the cryptographic signing of everything else within the container. And while it's not specifically the focus of this demo, just to explain what we mean by evolvable here, within Apptainer, you can add a ext3 formatted overlay image essentially to a built container that adds a writable layer to that container. These are typically immutable, as I mentioned. The SquashFS isn't really meaningfully modifiable because it's a compressed file system, so you can't really get in there and do anything with that. But if you wanted to have some type of writable space for a container, like for example, you have some type of workload, high-performance computing workload represented within a container that you want to have outputs written to a place that they're also packed with that container. You can add a writable overlay, whether that be as an ext3 image or a directory on your file system that the container can use for reading and writing, or not reading and writing, sorry, they can use to write to. This kind of touches on some of the optimizations that Apptainer provides kind of surrounding how it stores data within inside of it. Just to give the typical use case, if you're running some type of high performance computing system with thousands of processes starting up, all of those doing small file IO, Python imports, that type of thing. your file system can bog down with doing all of those different small metadata operations. But instead, if you're running out of a container and all of those metadata operations across your shared file system on your compute cluster, if instead all those metadata operations are just directed to the squashfs inside of the container, and it basically just becomes reading offsets into that squashfs, these read operations happen much, much faster. And for the same reason, if you're using an X3 image overlay, the writing happens a lot faster because instead of metadata operations on actual file system, it becomes just reading offsets into an overlay image, basically. So that's a bit of a long-winded explanation, but that's what's inside of a CIF. That's what can be inside of a CIF as well if you make certain modifications to it. But you can see how the format allows for, as we've touched on in various capabilities, a lot of very interesting features that are good for HPC. And yeah, it kind of contributes to why we do things with Apptainer and not other containerization platforms within the context of a high-performance computing environment.
That's fantastic for us, and it brings up an interesting point. I know, Greg, you talked about this yesterday, and being able to have a real-world example of being able to do AI training into a container like that. Could you tell us that story about what that really means, having the ability to have that writable space inside of the container?
Sure. Is that for me or Forrest?
I asked you, but I don't care. Forrest wants to tell it. Jonathan, anybody.
I think what we're going over here is kind of a use case we discussed yesterday for the ability to selectively sign different components inside of a container. You may have noticed that when we were doing all those verifications and lists and stuff, there was, in addition to kind of a component ID for that def file, those two JSON files and that squashfs, there was also a group ID that was associated with those. And you'll notice that when we were looking at those signatures, it says that, as Jonathan pointed out, it shows that we've signed with that key the objects in group 1. This kind of leads to an interesting use case where if you have, for example, evolving data that you want to move with a container, like, for example, you have a machine learning use case that you need to have data constantly being, or new data constantly being fed into. Like maybe you're developing your model, you're developing your data set, you want to be able to say easily pass all that code and all that data around people in your research group as that data still develops and those data sets kind of take shape. Something that you could do in order to provide verification there is sign all of those group 1 objects inside of that container. So sign the actual base image, the definition, stuff like that. But then add an overlay into a different group inside of that container that is then unsigned, but remains mutable as a result. And so you can have the base code and the base container that, say your model code and stuff is stored in, being immutable and being verified and signed by people in your research group. But you can actively still modify that overlay that contains, say, the images and the data that your model is supposed to run over. You can still easily modify, add to that, remove from it, whatever you need as your kind of whole code and project takes shape. In a way that, as I mentioned, keeps the original stuff still verified, but provides access to editing that.
I just want to mention as well that my artistic abilities in Google Slides have come a long way since then. I'm actually that image. It's funny. It brings up memories for us. it's an older image. I created it for, I think it was supercomputing presentation. I know Yannick committed it to the repo, but yeah, that's my old artiste work right there. You can also see that the image is actually based also on an ELF binary image, so it lends itself to a lot of functionality in terms of being able to extend and do different types of things with that image. And something we didn't mention, but we've mentioned before, is that the image itself is executable. So if you have a Singularity file container and you've specified a run script, you can actually execute that container like a binary. You can put it in your path, and it will actually execute the stack within the container like it would any other program. So it is super cool. A lot of functionality with regards to that, and it's quite extensible. Jonathan, I think you came off mute, but I didn't stop blabbing.
No, I didn't know how far you were going to go into that, but that was one of the first really aha surprise moments for me, was seeing precisely what you just said, that because of the use of an extension of the ELF format, you can just / your container and it runs. It's pretty cool.
That is very cool.
Mm-hmm.
So I think we had a couple of questions that popped up. I think Justin was the first one. So why is there a difference between a local and a remote key?
So in general, this is just the reality of the exercise. It's just reporting whether the key is stored locally on the computer or was pulled down from a key server. And Apptainer by default right now is configured to use OpenPGP's kind of general public key server. So remote keys are coming from there. But you may want to know when you're verifying something where that key is. You can pull that key down from the key server. I think it's Apptainer key pull and then the fingerprint, and it will be copied into your local key ring. And then it would be reported as a local key. And in general, you could imagine, it's just public key material. There shouldn't be a barrier to uploading that key to any key server. And so why does it matter? Like what? But even in this scenario, like I passed our demo key to Forrest out of band because I don't want to just throw random public keys with an email address that are never to be used again up into the key server. So we have that flexibility, whether it's for some privacy reason, maybe you don't want that key up on a public key server, or just for convenience, you just want to be testing something to work just with local keys. Similarly, in general, those public key servers are write only, or you write to them and the keys never go away. They can be revoked, they can be marked as inactive, but they are never deleted. But it's still an external service that you're dependent on. So if you have a production level service that depends on the ability to verify a key, you probably want to pull that key locally and be verifying it with your local copy rather than expecting to always be able to go out to the internet and pull that key down off the remote service. So it's just the specifics of where the key happens to be located right now, and then reporting that to you because it may matter in some circumstances.
Just to follow up on the last point that you just mentioned, it is important, I think, to know, because not all levels of trust are equal. So let me give an example of that. The key that you sent to Forrest over Slack, right? You could have been not just sending it over Slack, but you could have also been doing a verbal verification of that fingerprint with Forrest specifically. So typically, keys that are locally installed are ones that people consider most trusted. These are the ones that I now know. This is my trusted key ring. And that has an implied greater sense of security and trust than one that I'm downloading from a service on demand over the internet. So really, if somebody wants to have that level of trust, what would happen is Forrest would basically call up Jonathan and say, I found your key on this public, key service. I'm pulling it, and I just wanted real quick just to verify your fingerprint. Is this the right key? And just verbally go over the last 6 characters or however many characters you want, just to make sure that you trust that key. And then when you import that into your local key ring, you know for a fact that that key came from Jonathan, and now anything signed with that private key can be trusted with that public key. So it really just demonstrates that, as well as Jonathan was saying, to let you know how we are verifying any particular container. And I think the colors were green for local and yellow for, if I remember correctly, for remote, which basically it's green is good. Locals remote is, you may have a little bit of a warning that you want to pay attention here, and maybe you want to validate that, by hand. And then, of course, if that's something you're using a lot, you can import it. One other facet I'd just throw out there was, we're talking about local versus remote keys. We already mentioned execution control lists, and ECLs are a really important way to guarantee that the containers you're using and the containers that a system administrator on a particular host allow. If you're going as far as to implementing an execution control list for a particular container set of container fingerprints, you probably want to make sure that those fingerprints are actually local. Not that there's an easy hack here, but it is theoretically possible that a malicious user can redirect that request so it goes to their fingerprint, a PKI type service, and then get somebody to run some malicious code. It's very or it's a remote. There's a lot of underwork that needs to happen for an exploit of that magnitude, but it is in theory possible. So if you're going to go as far as to execute, execution control list, you probably also want to make sure that you're properly managing those keys and validating those keys locally in key rings.
And in fact, the execution control list feature doesn't even interact with remote keys at all. For those keys to be verified, they have to not even only be in your local key ring, but Apptainer, something we didn't demonstrate is Apptainer has a key ring for the user, but it also has a key ring globally for the system, just for public keys. And ECLs only validate based on the keys that are in that global key ring. So it's not enough for you to have it. It's not enough for it to be present. It's the systems administrator that configured ECL in the first place has to have imported those keys as well.
I completely forgot that. You're right, though. I remember it now. Thank you.
Very nice. So we have more questions coming in. One of them's been sitting there for a little bit. Kiddos. When would you use CIF encryption compared to CIF signing? And then are the two features complementary, or do they support each other? Like, why would you do one versus the other and not both?
So signing is to verify that to verify the integrity of the container, that it has not been modified since it was published to some degree of trust through the key material that you have from the past. But it doesn't protect the content. It doesn't obscure the contents of the container from the person who receives it, and from taking it apart, seeing what's in the container. If you need to do that, if the data that's stored in the container is itself secret, that's where you would use encryption. And you should be able to sign containers and encrypt them at the same time. And some software environments kind of do those together by using the same keys to sign and encrypt at the same time. Apptainer seems to use a different mechanism, just straight RSA keys for signing rather than the PGP mechanism. That's something I personally need to look more into. I don't know, Greg or Forrest, if you have more specific experience talking about them.
There's kind of a neat feature that you can do, which is you can actually encrypt. So let's say, for example, we went through this process. Forrest obtained Jonathan's public key. So we can now, if Jonathan were to share a container to Forrest again, we can validate that. Forrest knows for a fact that this is trusted. Forrest can now create a container using the reverse process and encrypt it using Jonathan's public key, which Forrest has. Once that has been encrypted, Jonathan would be the only person in the world, well, whoever has access to Jonathan's private key material and encryption or decryption key, Jonathan would be the only person who would be able to actually open up that container and look at the contents of it. So you can now think of kind of in different use cases where you can now verify trust and integrity of not only the contents, but who actually signed that. You can layer signatures to manage provenance of containers, manage it as it goes through, let's say, a DevSecOps cycle, right? Here's the author signs it. Maybe the security team signs it. Maybe the production team signs it. And you require all of those signatures for a container to run on a particular infrastructure. So you can manage all of that. But that's the signing, right? We're not actually encrypting the data within that container. So we can do encryption of that data plus the signing. And you can imagine the level of security and trust that you're kind of building in that. So Forrest could be not only encrypting the container that he's sending back over to Jonathan, so only Jonathan can open it, but Forrest can also sign that container, hand his public key over to Jonathan. And now Jonathan knows it came from Forrest. He knows it hasn't been messed with. And Jonathan's the only person who can actually open up that container and evaluate and leverage those contents.
That's very cool. Very cool. All right, George, we got a few questions from you. I think the first one was, what open source key server can Apptainer integrate with?
You want me to take it since I'm already talking and unmuted?
Absolutely.
Yeah, go right on ahead.
So Apptainer is leveraging standard protocols here. So HKP, I forget exactly what HKP stands for. Y'all can look it up, but HKP is the protocol that we're using to actually move the keys around. It is a standardized protocol, which basically means pretty much any key server that or PKI infrastructure that leverages HKP as that protocol will automatically just work with Apptainer. So we would be able to immediately just start, pulling keys, pushing keys. And this is why we're using a very common public key service to do this. So it's very easy to integrate this with any kind of key server.
So that was the first one. Next one is it possible to build and sign containers from a CI pipeline?
Another great one. I'll take it just because I'm on a roll at this point, but I do fully expect Jonathan, Forrest, and Zane to add if I mess anything up or miss anything. Yes, absolutely. Obviously, there's some integration that you would have to do into your CI pipeline with regards to secrets. And unless your private key is not encrypted, which I don't recommend, especially putting it up into a CI pipeline or infrastructure. So it'll probably have some sort of secret associated with that. And you're going to have to leverage your CI pipeline infrastructure to properly manage that secret and that key material. But assuming you do that properly, yes, it's absolutely possible. And I kind of just alluded to it as I was talking about a DevSecOps pipeline, where basically you'd have maybe a Git operation that causes a CI to go off and build your container. Then you have multiple pieces of this pipeline or multiple processes in this pipeline to do things like not only build, but now actually run various security compliance validations against it. You can do container scanning against it. You can do all these different pieces. And again, you can be signing them every step of the way such that the resulting container is absolutely guaranteed to be trusted. And you can host that once it's been signed. You could literally host that anywhere. As a matter of fact, people are actually hosting this within registries that are part of or associated with CI pipelines. So various CI infrastructures now are actually offering OCI-based registry support, and Singularity works directly as Apptainer. Sorry, Apptainer works directly. Zane, I'm going to blame you for that one. Apptainer works directly with these various registries that are supporting ORAS. And ORAS is, I think it's OCI registry as storage, if I remember correctly what ORAS stands for.
You got it.
Awesome.
Mhm.
And it basically allows us to store and persist the Singularity blob directly. And that was the mechanism that we actually demonstrated just a moment ago with Jonathan sharing that container to Forrest. He was actually using ORAS to do that. So a lot of ways you can integrate this into a CI pipeline. And this is definitely the trend that we're seeing from most organizations in terms of building their containers and integrating those containers with HPC. And then they do that in an automated fashion such that their containers are always up to date. And then when they go to integrate them into the HPC system, they can have either automated ways of doing that, or if we're talking Fuzzball will automatically pull from a particular tag. So if you're building from a CI pipeline as something like latest, or tag is latest, or the tag is production, or whatever you want, you can always ensure that you're pulling that version of that container in an automated way. And the infrastructure manages all of that. In an HPC system, it's one extra step, but it is, so it's CI, not really CD, or manual deployment. So MD. CIMD, that's what it is. But basically, it gives you that ability to automatically be building those containers, signing, trusting those containers, and then sharing appropriately with your infrastructure.
Very nice. I think we just had another question that popped in. Is it possible to lock down execution to only allow containers that have trusted signatures to run? I think, Jonathan, you touched on this a little bit earlier, but I would rather you answer it again.
Yeah, so this is the execution control list function. It's just a config file that exists globally for the system. So it's not a per user setting, but within kind of the general Etsy Apptainer directory structure, there's an ECL dot something file that allows you to specify one to many blocks of configuration for containers under a certain path. And you can give either a list of signatures or a list of fingerprints for keys that must have signed or may not sign. So you can block containers with certain signatures. You can require that all of the signatures in a list are present on a container, or you can give a list of signatures, any of which would allow it to run. And then you can lock that down for, only verify containers that are in /temp, or only verify containers that are in certain directory structures, and require that your containers be in certain places as well.
Very cool. Thank you. So we're actually running up against time here, guys. So I'm going to wrap up, but I'm going to leave it open to you guys. If you have any closing thoughts you want to add, Greg, you have to go last. So I'm going to start with Forrest.
No, nothing too much from me. We have that picture of Jonathan as the supercomputing mascot.
Oh, nice.
I want to throw that up there. But I'm not sure if we want to, but I thought that was kind of funny. That does actually look like Jonathan to me.
Throw it up.
Oh, sorry, I need to probably share this. My apologies. It's right here. If I can find where I put my StreamYard in among all these links.
Too many tabs. Not enough time.
I think that's Jonathan.
So this is me many years ago.
That's awesome.
There's a lot of story behind that, but I'll leave that for another day.
That's awesome.
That's cool.
All right, Jonathan, you have anything to close with here?
No, first time on here. Really happy to be with the team, and glad to be finding ways to contribute and work with all of these Apptainer and more fuzzball. It's all very cool.
Thank you for joining. Thank you for putting the demos together too. Appreciate it.
Yeah, absolutely.
Greg?
I like how you saved me for last. Is that because I talk so much? I'm just gonna.
No,
it's because we're hiring.
So a couple points. Yes, we are hiring, and we are very happy to have Jonathan and Forrest with us. Forrest has been with us for a little while, and the team is growing. So if this is stuff that interests you and you want to be part of it, definitely reach out to us. Let us know. The other thing I'm going to make a comment on is the amount of times that we call Apptainer Singularity, and this has to do with the fact that it started life as Singularity. I created Singularity back when I was at the Department of Energy at Lawrence Berkeley Lab and joint appointment to UC Berkeley. I have to make sure I give all credit where credit's due to my employers. Singularity came to be over there. We prototyped it, we brought it out to the community, and it's been a fantastic tool for a really long time. There's been corporate involvement with regards to Singularity, and we want to, but moving forward, we always want to make sure that the project stays in the community 100%. And so Singularity has been moved into the Linux Foundation. And as part of that move, the Linux Foundation asked if we could rename the project just to make sure that they have the ability to protect the project and the name and the branding of that project as best as they can. And Singularity, as you may know, is a term used all over science, research, and everything else. So we put it out to the community, and the community spoke and voted, and Apptainer is what was chosen. It was chosen because it is an application container system. And so it made a lot of sense. But that is why old memories, muscle memory, inertia is very, very difficult to break at this point, because there is many years of legacy of calling it Singularity. But the project is the same. It is taking on a new life as Apptainer, but it is a absolute simple transition. There's another webinar that we did specifically on that. And And being associated with the Linux Foundation, having the Linux Foundation run that project is of massive benefit to the community first and foremost. And that's the message really I wanted to get across. So see, I told you I was going to talk a lot. Sorry.
No, that's great. And the part of the Linux Foundation, it's actually getting more exposure and exposed to other things and allowing for more integration. So it's just growing faster and faster and having more people interested in it. So thank you for sharing that, Craig. Again, we're hiring. Check out the site. If you're interested in any of this stuff, like and subscribe so you can stay in touch with us. And if you ever need any help or you ever want to talk to us, just reach out on the site. We'd be happy to schedule a consultation with you and talk through your needs, what you like, what you don't like. And just thank you for joining us. And we will see you next week. Thank you.
Bye, everyone.
Thanks. Bye.